Hi all the students. Today we are going to study fundamental circuits in graph theory. So let's see what are fundamental circuits. If we add an edge between any two vertices of a tree, a circuit is created. We know that a tree is a minimally connected graph. Minimally connected means that there is only one path between any two pair of vertices which is sufficient enough, right? There is no more than one path between any two pair of vertices in a tree and no less than one also. So it is connected graph but a minimally connected graph. That is, there are no additional paths to reach from one vertex to any other vertex in a tree. So there is only one path between any two pair of vertices. Now you know, when we create an additional path, a circuit is created, right? So this is what happens in case of a tree, that when in a tree an edge is added between any two vertices of a tree, an additional path will be created between those two vertices and hence a circuit will be created. So this is what just I told you, why this happens, why a circuit is created when we add an edge between any two vertices of a tree. Because as I told you, there already exists one path between any two vertices of a tree, and adding an edge between them creates an additional path between them, and hence this additional path creates a circuit. For example, if we consider this tree, in case of this tree, if I take any two random vertices, for example, if I take these two vertices, now there already exists a path between these two vertices. The path is this. These shaded lines are representing the path from this vertex to this vertex. But if I create an edge between these two vertices, then an additional path is created. One path was this and the other path is now this one. So when this additional path is created, you can see that a circuit is created in this tree. One additional path creates one circuit, right? Now if I forget about these two vertices, say for example, and if I consider these two vertices, now in case of these two vertices also, you can see there already exists a path. These dashed lines represent the path to reach from this vertex to this vertex. Now if I add an edge between these two vertices, then what is this path? This is an additional path, and this additional path creates a circuit. So whenever in a tree we add an edge between any two vertices of a tree, an additional path is created, and this additional path creates a circuit. A connected graph. From this we can also conclude that we can say that a connected graph is a tree if and only if adding an edge between any two vertices of the graph, which is a tree, creates exactly one circuit, right? So we can say, if we do not know whether the graph is a tree or not, and if we have a connected graph, and if adding an edge between any two vertices of the graph, one circuit is created. You add one edge and one circuit is created, then you can say that that graph is a circuit, that graph is a tree, provided you did not have a circuit before. You have a connected graph which is completely circuitless, and then if you add an edge between any two vertices of that connected graph, and by adding one edge you get one circuit, that means there did not exist any other circuit before. You have only one edge, one circuit after adding one edge, so that means there did not exist any circuit before. Only a new circuit has been formed after adding a new edge. That means this is a tree, because only in the case of trees, when you add one edge you get one circuit. So if you added one edge, you got one circuit. That means there did not exist any circuit before, and hence you can say that such a connected graph is a tree. Now let us consider a spanning tree T in a connected graph G. We all know a spanning tree T is such a subgraph of a graph G which is a tree and which covers all the vertices of the graph G, right? So any such subgraph which is a tree and which covers all the vertices of its graph is called a spanning tree. Now if I add any one chord to this tree, it will create one circuit, right? Now this is in case of a spanning tree. In case of a tree, you know, when you add one edge to the tree, one circuit is created. But when this tree is a subgraph of another graph, that means when it is a spanning tree, in that case when we add one chord to this spanning tree, what is a chord? A chord is that edge which is a part of the graph but which is not a part of the spanning tree. That means you add an edge which is additional to the spanning tree, which was not a part of the spanning tree, which was added additionally, because here we are talking about additional edges. So in case of a spanning tree, what will be the additional edge? Any edge outside of the spanning tree, which is the chord, because we know the edges of the spanning tree are known as branches. So when we have to refer to an outside edge that is not part of the spanning tree, but of course it is a part of the graph, so that we say chord. Any edge which is a part of the graph and not the spanning tree is the chord, and any edge which is a part of the spanning tree is a branch. So if we add any chord to the spanning tree, obviously it will create exactly one circuit. You add one chord to the spanning tree, it will create exactly one circuit. So such a circuit formed by adding a chord to the spanning tree is called a fundamental circuit, right? So understand the difference between a circuit and a fundamental circuit. When we add an additional edge to the tree, here I am not saying spanning tree, I am saying tree. When you add an additional edge to a tree, it is called a circuit. For example, if you consider this particular graph, this is a tree. But this is not a spanning tree, because this tree is not a subgraph of any other graph. It is a complete graph in itself. So this is a tree. This is not a spanning tree. And when you add an additional edge to this tree, it gives you a circuit. But in case of a spanning tree, when you add an additional edge to it, in case of a spanning tree, the additional edge will be that edge which is outside of the spanning tree and inside the graph. So that edge is called a chord. That is why we are referring to a chord in case of a spanning tree. In case of a simple tree, in case of a tree, we were referring it to as an edge or as an additional edge. But in case of a spanning tree, we are referring it to as a chord, because it is not a part of the spanning tree, but it is a part of that graph of which this spanning tree is a subgraph. So such an edge which is not a part of the spanning tree but is a part of the graph of which the spanning tree is a subgraph, we call it a chord. And any such edge which is a part of the spanning tree is called a branch. So what will be additional to the spanning tree? Obviously the branch will not be additional to the spanning tree because it already exists in the tree. Those are the existing edges of this spanning tree. So what edge will be additional to the spanning tree? Chord. And here in case of circuits, we are referring to we are considering the additional edges. So with respect to a spanning tree, what will be the additional edge? The chord. So just like adding one edge to a tree gives you a circuit, adding any one chord to a spanning tree will create one circuit, and this circuit which is created by adding a chord to the spanning tree is now referred to as the fundamental circuit. So this is the difference between a normal circuit and a fundamental circuit. That is, a circuit is created by adding an edge to a tree, and a fundamental circuit is created by adding a chord to a spanning tree. So just like by adding one edge to the tree, we get one circuit. Similarly, by adding one chord to the spanning tree, we get one fundamental circuit, right? So this is the difference between a circuit and a fundamental circuit. Circuit is with respect to a tree and a fundamental circuit is with respect to a spanning tree. So basically, how many fundamental circuits will a spanning tree have how many fundamental circuits will a graph having a spanning tree have? Exactly as the number of chords, right? One chord gives you one fundamental circuit. So how many fundamental circuit will a graph have having spanning trees? As many fundamental circuits as the number of chords you add to the spanning trees of that graph. Now, if I consider this graph, since we are talking of spanning trees, since we are talking of fundamental circuits, so we will consider spanning trees over here. So for a spanning tree, of course, you need to have a connected graph first of all. So let us look at this example. You can see that this is a connected graph. This is one connected graph. Now this connected graph has a subgraph which is a spanning tree. This subgraph of this graph is a spanning tree. So if I denote this graph by G, then its subgraph, which is a spanning tree, is denoted by T here. So this is the main connected graph. Its subgraph is a spanning tree. Now all those edges which are highlighted in red lines represent the branches of the spanning tree. So basically you can say that all the blue lines or the blue edges are the chords and all the red lines are the branches. Blue lines represents the chords and red lines represent the branches. So basically from the red lines you can figure out the skeleton of the spanning tree. This is the spanning tree. So if I take out the spanning tree from this connected graph, this is what I have. This is the structure or the scaffolding that I have. This is my spanning tree, right? Out of this connected graph, this is my spanning tree. And any circuit which will be formed in this spanning tree by adding a chord to this spanning tree will create a fundamental circuit, right? Now if you look at the spanning tree, it is made up of which all branches? The branches B1, B2, B3, B4, B5 and B6. These are the branches that make up the spanning tree. B1, B2, B3, B4, B5 and B6. And these are all branches because these are those edges which are a part of the spanning tree. Now adding a chord C1. As I said, we are talking about fundamental circuits, and a fundamental circuit is formed by adding a chord to the spanning tree. So that means we need to add a chord to the spanning tree to find a fundamental circuit or to create a fundamental circuit. Now if to this existing spanning tree I add chord C1, you see chord C1 is an edge which is a part of the connected graph but not the spanning tree, because I told you all the blue edges represent the chords and all the red edges represent the branches. So if I add a chord C1 to this spanning tree, if I add a chord C1 to this spanning tree, this is how it will become. Now I have to this spanning tree, I have added one chord C1, and as per the definition, adding one chord gives me one fundamental circuit. And what is the fundamental circuit that I've got here? It is B1, B2, B3, B5 and C1. This portion is the fundamental circuit that I'm talking of. So here I get my fundamental circuit. This is my fundamental circuit because by adding one chord C1 to the spanning tree, I got one circuit which is called the fundamental circuit. So what is the fundamental circuit here? B1, B2, B3, B5 and C1. So the fundamental circuit that I get by adding chord C1 to the spanning tree B1, B2, B3, B4, B5 and B6 is B1, B2, B3, B5 and C1. So this is the fundamental circuit that I've got. B1, B2, B3, B5 and C1. So this forms your fundamental circuit, right? So this is what you call a fundamental circuit. Now we will elaborate this a little more. The same spanning tree I am considering. See, this is the same spanning tree which I am considering over here. I have drawn it The one which was drawn with the red pen is now drawn with the pencil. Everything is rest same, right? We have the same branches B1, B2, B3, your B4 and B6. All the branches are same. So this is the same spanning tree that I am talking of. Now, as I said that the spanning tree B1, B2, B3, B5, B4 and B6 is the spanning tree. If I add chord C1 to this spanning tree, you saw that I got one fundamental circuit. Adding one chord gives you one fundamental circuit. Now let us say if by adding chord C1 I got fundamental circuit FC1. And what was this fundamental circuit? This fundamental circuit was B1, B2, B3, B5 and C1. This is the fundamental circuit that I'm talking about. So after adding chord C1, I got the fundamental circuit FC1, which consists of branch B1, branch B2, branch B3, branch B5 and branch C1. Branch B1, branch B2, branch B3, branch B5 and chord C1. Now let us assume if I don't add chord C1. Instead of adding chord C1, I add chord C2 to the spanning tree. Right? This is the spanning tree and this is the chord C2. Right? From this connected graph, instead of picking up the chord C1, let us assume that this time I don't pick up the chord C1, I pick up the chord C2. So that means to this spanning tree, instead of adding chord C1, I add chord C2 and I remove chord C1, right? So this kind of a structure I will get. This is what I have depicted here, that instead of adding chord C1 to this fundamental circuit, this time I have added chord C2, and after adding chord C2, this is the fundamental circuit that I get, right? So I added one chord C2, I got one fundamental circuit, and let us say that by adding chord C2, the fundamental circuit that I get is, I name it FC2, right? When I added chord C1, the fundamental circuit that I got was FC1, one chord, one fundamental circuit. Similarly, if instead of C1, if when I added chord C2, so that means I added one chord. So by adding one chord to the spanning tree, I got one fundamental circuit named as FC2. So this is the fundamental circuit that we have got now, right? So when I added chord C2, I got this fundamental circuit which consists of branches B2, B3, B5 and a chord C1. So branches B2, B3, B5 and a chord C2. Sorry, the chord is C2, not C1. So the fundamental circuit is B2, B3, B5 and chord C2. This is chord C2 from here to here, right? So chord C2. So the fundamental circuit is B2, B3, B5, C2. So adding one chord gives you one fundamental circuit. Adding one chord gives you one fundamental circuit. If the chord is C1, you get this fundamental circuit. If the chord is C2, you get a different fundamental circuit, which is this, right? But if I add both the chords to the spanning tree, right? If I add chord C1 also and chord C2 also, this is how the spanning tree will look like. Adding chord C1 gave you fundamental circuit FC1, which you have already seen, and adding the chord C2 gives you fundamental circuit FC2, which you've already seen. So when we add both the chords C1 and C2 to the spanning tree, then apart from the two fundamental circuits just we have seen with respect to chord C1 and C2, we will get one more fundamental circuit which we call FC3. So obviously we get the fundamental circuits which we just talked about when we add both the chord C1 and C2. We get the fundamental circuit with respect to chord C1, which is FC1, and we get the fundamental circuit FC2 with respect to the chord C2. But other than that, we get one more, that is a third fundamental circuit also, which you can see highlighted in the blue line. And this fundamental circuit, I name it as FC3. It consists of B1, C1 and C2, right? It consists of your B1 this, C1 this chord. B1 is a branch of spanning tree. C1 is the chords, then the chord C1, and then the chord C2, because from here till here you are having chord C2. So this is the fundamental circuit, the third fundamental circuit that I'm talking about. It consists of branch B1, it consists of chord C1, and it consists of chord C2, right? So we get two chords here. This circuit will not be called a fundamental circuit. So I remove the word F from here. This is not a fundamental circuit, right? So the circuit that you get with respect to chord C1 is a fundamental circuit named FC1. The circuit that you get with respect to the chord C2 is the fundamental circuit FC2, but you get a third additional circuit which consists of both the chords C1 and C2, and hence it will not be considered a fundamental circuit. So a fundamental circuit will basically consist of only one chord. Like here the fundamental circuit FC1 obtained by adding chord C1 consists of chord C1, obviously by adding chord C1. And here the fundamental circuit FC2 obtained by adding chord C2 to the spanning tree is FC2. It consists of chord C2. But here you say, this was when we added either chord C1 or either chord C2 to the spanning tree. But as I told you, if I add both chord C1 and C2 to the spanning tree, then other than these two fundamental circuits, FC1 and FC2, I get a third fundamental circuit, third circuit also. I'm sorry, that would not be this fundamental circuit, but I get a third circuit also. Right. So when fundamental circuit is with respect to chord C1, fundamental circuit FC1 is with respect to chord C1, and when fundamental circuit FC2 is with respect to chord C2, and you get a third circuit also out of it. Though as per rule, the number of fundamental circuits will be equal to the number of chords. One chord, one fundamental circuit. One chord, one fundamental circuit. Here we have two chords, we have two fundamental circuits. And then emerged a third circuit which comprised of both the chords B1, C1 and C2. So this is not a fundamental circuit. You can call it a circuit, but you cannot call it a fundamental circuit because it consists of two chords C1 and C2. So you add one chord to a spanning tree, you get one fundamental circuit. You add two chords to a spanning tree, you get two fundamental circuits. And the third circuit which has appeared is not a fundamental circuit because it consists of two chords or both the chords C1 and C2. So this is how you identify or you find out the fundamental circuits in a spanning tree. So basically you can say that a circuit is fundamental only with respect to a given spanning tree. Here in this case, from the connected graph, I have taken out this particular spanning tree. This is the spanning tree which I am talking about. In this connected graph, I have taken out this spanning tree, and these fundamental circuits FC1 or FC2 that I am talking about are with respect to this spanning tree also, only. So the fundamental circuits FC1 and FC2 which we just saw were with respect to this spanning tree T, right? But that means their scope is within this spanning tree T only. But this connected graph can have more than one spanning tree. This is one spanning tree. It can have, say for example, another spanning tree T2. If this graph has another spanning tree T2, then these fundamental circuits FC1 and FC2 will not be valid for this particular spanning tree T2. That means, in other words, we can say that a circuit is fundamental circuit only with respect to a given spanning tree, but not with respect to a different spanning tree of the same graph. So these fundamental circuits FC1 and FC2 are valid only for this particular spanning tree, but not for any other spanning tree of the same connected graph.